Hi everybody, welcome back for notes 4.2. In this lesson, we're going to be studying the standard form of a quadratic equation. So let's talk about the standard form of a quadratic. You'll remember from last lesson that we talked about the parent function, where y equals x squared. We also then talked about the vertex form. So today, we're going to focus on the standard form. And that's the form y equals ax squared plus bx plus c. Now this form will look most familiar if you recall back to Algebra 1 when you talked about the quadratic formula. And you had to plug a, b, and c into negative b plus or minus the square root of b squared minus 4ac all over 2a. So that's why standard form looks familiar. Now, before we get into standard form, let's do a quick review from the last lesson about the interval, inequality, and set builder notations. So what we want you to do is we want you to pause the video and we want you to take this example, place it into interval notation, then inequality notation, and lastly, set builder notation. So hit the pause, do all three forms, hit play again, and we'll see if you got it right. Okay, let's look at this example. It says the domain is greater than negative 3 and less than or equal to 4. Well, if you recall from interval notation, the smallest number goes on the left and the largest number goes on the right. So that means I'm going to put negative 3, comma 4. Now, it says the domain is greater than. It doesn't say greater than or equal to. It says greater than. So negative 3 is going to get a parentheses. And then it says less than or equal to 4. So since it's or equal to, that means 4 is going to get a bracket. So it looks like that. Now, if you'll recall, we then change it to inequality notation. So again, 3 is going to go on the left, 4 is going to go on the right. Now, because this is talking about domain, we're going to put x in the middle. Now, 3 gets a strictly less than because it's not a bracket, it's a parentheses. And then 4, well, it gets a less than or equal to because it has a bracket and it says less than or equal to. Now you can verify this with the example above. It says the domain is greater than negative 3. So x is greater than negative 3 and less than or equal to 4. So it definitely says x is less than or equal to 4. Now, let's transfer this to set builder. So if you'll recall, set builder, we start off with the left brace, or as I like to call it, the birdie braces. So we'll start off with the left birdie brace. Since it's domain, it's going to be x and then slash. We're going to input the inequality notation and close it off with another birdie brace. So this would read the domain is equal to the set of all x's such that x is greater than negative 3 and less than or equal to 4. All right, let's talk about the rules for standard form. So before we get going, I want to point something out. The a value of standard form, that leading coefficient, that a value, the a in standard form is the same as the a in vertex form. So whatever your a in standard form is going to be whatever your a in vertex form is. That is the only value that will go back and forth between the two forms. Now again, standard form is just another way to express a quadratic equation. It is no different than vertex form in the fact that if everything matches up, it will graph the same parabola. It's just another way to write the equation of a quadratic. All right, so while we're there, let's talk about A. So just like in vertex form, if A is greater than 0, meaning it's positive, then that means your parabola is going to open up. If A is less than 0, meaning it's negative, your parabola is going to open down. All right. Now, in 4.1, we talked about the max and min over an interval. And you can most definitely always do max and min over a closed interval. However, we have something, and we kind of talked about it a little in 4.1, but your vertex will be what we call the absolute minimum or the absolute maximum. And by absolute, we mean that's the highest point on the vertex or it's the lowest point on the vertex. So yes, you can still have max and min over an interval, but your parabola itself has a true maximum and a true minimum. Okay? So if A is greater than 0, meaning it's positive, meaning it's going to open up, your vertex is going to be referred to as the minimum of the parabola. If A is less than 0, meaning it's negative, meaning it opens down, your A, or your vertex, I'm sorry, not your A, your vertex is going to be known as the maximum of the parabola. Okay, so A is greater than 0, meaning it's positive, meaning your parabola opens up. Your vertex is going to be the min. If A is less than 0, meaning it's negative, meaning your parabola opens down, your vertex is going to be the maximum of the parabola. So let's move on and let's talk about that vertex then. Okay? So we don't have H and K, so how are we supposed to find our vertex? Well, we have a formula. The x of the vertex, the x coordinate, is found by doing negative b over 2a. So you've got to calculate negative b over 2a. That is the x coordinate of your vertex. Now, don't let this fancy pants notation throw you off. That simply means to get the y, you're going to calculate negative b over 2a for the x, and then you're going to take that x value, you're going to plug it back into the x's of standard form and simplify, and that's going to give you your y. So again, don't let that fancy pants notation throw you off. To find the vertex, you're going to do negative b over 2a, then you're going to plug that back in for x, simplify, and that's going to get your y. Now, you'll notice, okay, so the vertex is an xy coordinate pair, but it's also the same as h and k. So h is the same as negative b over 2a. K is the same as, we take that value, plug it back in, simplify, and that's our k. Now, axis of symmetry. If you remember from vertex form, that was x equals h. Now you may be wondering, okay, so like, wait a minute, if I calculate negative b over 2a, do I have to then recalculate it to get the vertex, the axis of symmetry? The answer is no. If you find, now this is just an example, if you calculate that your vertex is 2, 5, you don't need to recalculate negative b over 2a. You can simply go, oh, x equals 2. So we're just showing you that there is a formula to calculate it, but remember, your axis of symmetry goes straight down through the x coordinate of the vertex. So x equals h, okay? So but we're just, like I said, we're showing you that a formula does exist. Now here is something really cool about standard form, okay? The y-intercept is always 0, c. So the c value always represents that y-intercept. Because think about it. if you plug 0 in for x, doesn't the first and second term, don't they both go to 0? Yeah. So your y-intercept is 0, c. All right. Next thing, let's talk about the x-intercept. So we learned in 4.1 that x-intercept is it's a synonym, solutions, roots, and zeros. So x-intercepts are solutions, are roots, and are zeros, which we're going to abbreviate as SRZs so we don't have to say that all the time. So again, these are the same as our x-intercepts. It's where the graph crosses the x-axis, and it's where y equals 0. So this is nothing new to us. Now, let's talk about the domain. Guys, it's still a quadratic. It's still a parabola. Your domain is going to be negative infinity to infinity. Okay? Always, always, always. But let's talk about range. Now, there's that fancy pants notation again. Guys, this is the same as k. So your range here, if a is greater than 0, meaning it opens up, this is the same as k to infinity. Okay? So do you have to recalculate it? Again, the answer is no. If you know your vertex, determine if it opens up, opens down, and then just use the k or the y value of the vertex. Now, if a is negative, meaning your parabola opens down, it's negative infinity to fancy pants notation. But remember, fancy pants notation is the same as k. So if it opens down, this is the same as negative infinity to k. So if you're totally cool with using negative infinity to k and k to infinity, don't change that, because once you know the vertex, there's no need to recalculate this stuff. All right, let's move on. All right, let's look at our first example. We're going to find all the attributes given the equation in standard form, and then we're going to graph it. So when you have to graph, the first thing you want to find, always, 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 is your vertex. Okay, now we know that's negative b over 2a. So I put a 1 there, I put a 1 there. My a is negative 1, my b is positive 1, and then c is 6, but we'll worry about him later. So I'm going to calculate negative b over 2a. My b is positive, so that becomes a negative 1 over 2 times a, which is negative 1. So that gets me negative 1 over negative 2, which is positive 1/2. So I've got the x coordinate of my vertex. Now I'm going to plug that 1/2 in for x, and I'm going to calculate what the y coordinate is. So that gives me negative 1/2 squared plus 1/2 plus 6. So I'm going to take care of my exponents first. That gives me 1/2, 1/2, which is 1/4. So negative 1/4 plus 1/2 plus 6. Now, I'm going to get all this in a common denominator, which is 4. So negative 1/4 plus 2/4 plus, well, 6 is 24 over 4. So negative 1/4 plus 2/4 is 1/4. 1/4 plus 24/4 is 25/4. All right. So now I know the coordinate of my vertex, 1/2 and 25 over 4. So now we're going to go to our table. So there's no parent function to shift off of when you're in standard form. So here's what you want to do. You want to put your vertex in the middle of the table. Okay, always, always, always your vertex is the middle coordinate. And then you're going to pick 2 x's to the left and 2 x's to the right. Okay, so 2 x's to the left, 2 x's to the right. Now here's the deal. Guys, don't make this difficult on yourself. Pick 2 integers to the left and 2 integers to the right. So you always want to have your vertex, 2 integers to the left, 2 integers to the right. Okay? Integers are going to make your life so much easier. Don't be messing with fractions unless you have to. So immediately to the left of 1/2 is 0. So if I'm thinking 0 and 1/2, that's how I calculate to the left. So immediately to the left of x equals 1/2 is 0. Immediately to the left of 0, the next integer, is -1. Now we're going to pick 2 integers on the right of 1/2. So immediately to the right of 1/2 is +1. And then immediately to the right of +1 is +2. So again, vertex in the center, 2 x's to the left, 2 x's to the right. Now, all I'm going to do is take each of these x's and plug them into the the standard form and calculate them. So I'm going to plug 0 in and I get 6. I'm going to plug -1 in and I get 4. I'm going to plug +1 in and I get 6. And then I'm going to plug +2 in and I'm going to get 4. Now don't always assume that it's always going to be the reflection. It so happened this time that it was, because 1/2 is equidistant to 0 as it is 1. So don't try to cheat the system and go, oh, it's just going to be a mirror reflection. Because if your fraction is 3/4, that's not going to be a mirrored reflection. It's not going to be that symmetrical on both sides. So again, don't cheat the system. Plug each separate x in and get its separate y. So I graph my function. And that's what the graph looks like. Let's talk domain, range, axis of symmetry, SRZs, y-intercept, x-intercept. Now, this is a parabola, so we know our domain will always be -infinity to infinity. Now my range, this guy opens down. He opens down. So that means it's going to be -infinity to k. And in this case, my k is 25/4. So it's going to be -infinity to 25/4. My axis of symmetry is going to be x equals h. So it's going to be x equals 1/2. So you see how I'm still using my knowledge from vertex form, because once I've got the vertex, I'm like, dude, I'm good as gold. I can just use what I know about vertex form. Now my SRZs, you're thinking, well, I don't quite know what they are. They're not on my table. So remember, your SRZs are the same as your x-intercepts. So we're going to set y equal to 0, and then we're going to have to factor and solve. Okay? So I'm going to say 0 equals -x² plus x plus 6. Now, we always want our leading coefficient to be positive. So the first thing I'm going to do is I'm going to factor out a -1. When I do so, that makes the equation become 0 equals -1 times x² minus x minus 6. Now I'm going to have to factor x² minus x minus 6. So, two numbers that multiply to make -6 that add to make -1. How about -3 and +2? Okay, so that becomes -1 times x minus 3 times x plus 2. Well, 0 will never equal -1, so he's out of here. 0 equals x minus 3, so that means x is 3. 0 equals x plus 2, well, that means x is -2. So x is equal to 3 and x is equal to -2. Now, here's where it differs a little, SRZs and x-intercepts. So SRZs, you can just write as -2, 3. So you can just put those in your solution set notation. So when you're talking SRZs, you just write what x equals. In this case, -2 and 3. But when we get to x-intercepts, please remember they have to be written as coordinate points. Okay? But before we get there, let's go find our y-intercepts. Now, you can revert back to, okay, I'm going to plug 0 in for x. And you're totally welcome to do that. But if you remember back from the chart we just looked at, your y-intercept is always c. Well, your c value up here is 6. So it's just 0, 6. But again, you could plug in 0 for x, and that would be totally cool. Okay, so x-intercept. We've already set y equal to 0. We've already factored. We've already solved. Yay! So, but remember, we're going to write these as intercepts now. So that means it has to be x, 0. So I'm going to turn that into -2, 0 and 3, 0. Now, essentially, do they mean the same thing? Yes. But just remember, when you're writing SRZs, or when you're writing them as SRZs, I should say, when you're writing them as SRZs, you put it in the solution set notation with the birdie braces and the comma, and woohoo, life's grand. But the minute you say, okay, they're also the same as x-intercepts, you have to write them as coordinate points. All right, so back in 4.1, we talked about how to convert vertex form to standard form. And I kind of alluded that we're going to go the other way in 4.2. So now that's what we're going to do. We're going to convert standard form back to vertex form. So if you remember, when we were looking at that chart, I told you that the A value in standard form is the same as the A value in vertex form. So to go to vertex form, if you remember, we're going to need 3 things. We're going to need A, H, and K. We're going to need A, H, and K. So, what is A? Well, again, A in standard form is A in vertex form. So, my A is 1. Now, I need to calculate the HK. I need to calculate the vertex. So remember, H is the same as the x-coordinate of the vertex, so it's -b over 2a, and then we're going to plug it in. So the first thing we want to do is -b over 2a. So 3 is positive. It's going to become -3 over 2 times 1, so that becomes -3/2. Woohoo! We found the h. Now we plug that back in for x. That's going to give us the y, or the k value. So I plug in -3/2 for x. So -3/2 squared plus 3 times -3/2 minus 4. So -3/2 times -3/2 becomes +9/4. 3 times -3/2 is -9/2. And then we have minus 4. So now I'm going to get it all in a common denominator, which in this case is 4. So 9/4 plus -9/2 becomes -18 over 4 minus 4. Well, that becomes 16 over 4. So now I just add 9 plus -18 is -9. -9 minus 16 is -25 over 4, which is my k value. So all right, I have A, H, and K. So I have to just write the equation and sub in the values that I just found. Now, the question is, do I have to put that 1 in front? The answer is no. You don't have to. If A is 1, you can write it, you can leave it off. They're both mathematically correct. So, and if you'll notice, my H was -3/2. So when I wrote it in the equation, it became x plus 3/2. Okay, here's a fun problem. It says given y equals ax squared plus 10x plus c, and the vertex of -5, -27, let's find the value of a. I'm given the vertex. I'm given an equation in standard form, but I only know the b value. If only there was a formula that related a piece of the vertex to the b I know and the a I don't know. How about h equals -b over 2a? Or the x-coordinate of the vertex equals -b over 2a. Because remember, your vertex is also hk. So what I'm going to do is I'm going to take the h of my vertex. I'm going to set it equal to -b over 2a. I know b. That's 10. And then we just have to solve for a. Oh my gosh, this is like so easy. So I'm going to plug in -5 for h, -10 for b, because remember b is +10, so -10 over 2a. Now you can do one of two things. You can multiply both sides by 2a, blah, blah, blah. Or I'm going to put it over 1, and now it's a proportion. How do I solve a proportion? I cross multiply. So I get -10a is equal to -10. Woohoo! All right, I divide by -10, and I get a is +1. Sweet, I'm done. And then, okay, so like we're going to be done with this for now. But if you wanted to go back and find the c, you could use your a value of 1, your -5 for your x values, -27 for your y values, and then you could solve for c. But I'm just saying. Here's a hint for number 28 on your homework. Just saying. You might see something like this again. Okay, let's look at a word problem that's going to utilize standard form. Again, word problem, application problem. Application's all fancy pants. Word problem is word problem. So it doesn't matter what you really call it. We're just going to utilize standard form to calculate the dimensions of a rectangle. All right? Okay, so it says the dimensions of a rectangle are 3x and 20 minus 2x. Part A says, write an equation in factored form for the area. So, well, we remember from geometry, really like 3rd or 4th grade, but you did geometry back then too, that the area of a rectangle is length times width. Now again, it doesn't matter which one's length and which one's width. They didn't specify, so you can use whatever order you want. Now, I'm old school, so I'm always going to put the monomial first. So area in factored form is the area equals 3x times 20 minus 2x. So that's the equation for the area in factored form. Part B says, what dimensions will give you the greatest area? What dimensions will give you the greatest area? So we're wanting to maximize the area, and we want to find out what dimensions will maximize the area. So we're going to have to do standard form. So the first thing I'm going to do is I'm going to multiply by 3x. So that gets me 60x minus 6x squared. Now, standard form means highest exponent on the x to constant, okay? So you want to write this in decreasing order of the exponents. So before I do anything, I'm going to flip that around so that it is in standard form, -6x squared plus 60x. So if you multiply it, it's not in standard form, please flip it around so that it is in standard form. Now, let's think about this. What represents the maximum of a quadratic equation? What represents the maximum of the quadratic equation? Let's think about that table I showed y'all a few slides in. I know what it is. It's the vertex. Okay? The vertex represents the maximum, and we know it's going to be maximum because a is negative. So our parabola opens down because a is less than 0, so therefore our vertex is the maximum. So we want to find out, we need x to get the dimensions. Okay, so we really need to solve for x, which is really the h of the parabola. So we know x is negative b over 2a. So I'm going to use the b of 60 and the a is negative 6. So that gets me negative 60 over 2 times negative 6. So that gets me negative 60 over negative 12, which is equal to 5. Woohoo! I've got the x value. So the maximum of that parabola is the vertex. I've got the x value. So now I can use that x to go back and calculate the dimensions. So 3 times x, 3 times 5 is 15. And then 20 minus 2x. Well, again, x is 5, so 20 minus 10 is 10. So the dimensions of that rectangle that will give me the maximum area are 15 and 10. So our rectangle is 15 units by 10 units. All right, what if I wanted the maximum area of the rectangle? Oh my gosh, just multiply length by width back together. So 15 times 10 is 150 square units. All right. Now, coincidentally, if I had plugged 5 back into the area, it would have also given me 150 units. So there's 2 ways to do it. You can multiply your dimensions, or you can take your x value of 5, plug it back into the area, and that will give you the maximum area. But we also remember the question. It wanted to know the dimensions of the rectangle. So let's say if somewhere in our very possibly near future, we were to ask you, hey, these are the dimensions. What dimensions will maximize the area? All you do, you multiply them, put them in standard form, and calculate the vertex. Or if it were to say what would give us the minimum area, you'd calculate the vertex because a would end up being positive. So again, area equals length times width, multiply them together, calculate the vertex because that's the max or the min of the function, and then use that x to plug back in to get your dimensions. Let's look at another problem. It says a cat tosses a ball off the cliff modeled by the function f of x equals negative 4x squared plus 8x plus 60, where x represents the time in seconds and y represents the height in feet. So this is going to be very important information that we need to know. X represents time in seconds, y represents the height in feet. Okay, so first thing we want to find is, let's find the y-intercept, and then we're going to talk about what that means. Well, the y-intercept, that's where x equals 0, right? So I'm going to substitute 0 in for x. Now, when I clean that up, it becomes 0 plus 0 equals 60. So that means the function evaluated at 0 equals 60. What exactly does that mean? Well, let's go back up here. X represents time in seconds. Y represents height in feet. So if that's X and that's Y, that means that at time 0, the height is 60. Oh my goodness. So that represents the initial height of the ball before it dropped, really kicked off the curve, off the cliff. So here, what this is saying is that the initial height is 0. So before that cat kicks that ball off the cliff, it starts at an initial height of 60. So that's where the cat is, that's where the edge of the cliff is. Okay? So the initial height is the y-intercept. The initial height is the y-intercept. Okay? Now, watch the ball. Keep your eye on the ball. Watch the ball. Boop. Moved up the curve. So the cat has now kicked the ball, and that's where it's located. Same equation, same function. X still represents time in seconds. Y still represents height in feet. So let's find the vertex. Let's find the vertex of this curve. All right. So the vertex, that's x equals negative b over 2a. Okay, so I did negative 8 divided by 2 times negative 4. So that's negative 8 over 8, which is 1. So the x-coordinate of my vertex is 1. Well, we still need the y part, the y-coordinate. So I'm going to plug in 1 for x and evaluate it. So negative 4 times 1 squared plus 8 times 1 plus 60. Well, 1 squared is 1 times negative 4 is negative 4. 8 times 1 is 8 plus 60. So negative 4 plus 8 is 4. 4 plus 60 is 64. So that tells me my vertex is 1, 64. So, okay, cool, we found the vertex, but what exactly does that mean? What does it mean? Well, let's go back up here. X represents time in seconds. Y represents height in feet. So again, that's time, that's height. Well, the vertex, parabola opens down, so the vertex is going to be the maximum point. So that means that at 1 second, the ball reaches its maximum height. So the vertex represents the time at the maximum height. Let me say that again. The vertex represents the time that the ball achieved maximum height. One more time. The vertex represents the time at which the ball reached maximum height. So the initial height, if we want to know where it started, the initial height, that's your y-intercept. If you want to know the time at max height or when something reached its maximum profit, maximum whatever, in this case, time at max height, you're looking for the vertex. Okay, watch the ball again. Keep your eye on the ball. Boop. Now it's all the way down at the ground. So let's calculate the x-intercept or intercepts and explain what that means. Well, the x-intercept, that's when I plug in 0 for y. So I'm going to plug in 0 for y. Oh my goodness, now I've got to factor this. I've got to remember back from Algebra 1. It's okay, you're going to survive. It has a leading coefficient of negative 4. Does 4 go into 8 and 60? The answer is yes! Yay! 4 goes into 8 and 60, so I can factor out a 4. But wait a minute, remember we always want that leading coefficient to be positive when we're factoring? So we're actually, instead of factoring out a 4, we're going to factor out a negative 4. So let's factor out a negative 4 as a GCF, and that gets me x squared minus 2x minus 15 when I factor out that negative 4. Okay, now I can factor this. Now I got this. So I need two numbers that multiply to make negative 15, but also add to make negative 2. So, that's like negative 5, positive 3. That works because negative 5 times positive 3 is negative 15, but negative 5 plus positive 3 is negative 2. So it works. Don't forget that negative 4, because if you leave that GCF behind, it will not multiply to make the same thing, y'all. So 0 equals negative 4. Never going to happen. We can toss him. 0 equals x minus 5. Well, that means x is 5. 0 equals x plus 3, so x is negative 3. So I get two solutions of x equals negative 3 and 5. X represents time. Do you see a problem right here? If x represents time, can time be negative? Nope. So negative 3 isn't going to work. That's going to be like our extraneous solution. Yes, it's a solution to the equation, but it doesn't work in the real life problem. So negative 3 is extraneous, but 5 works because time can't be negative. So x equals only 5, or we have a x-intercept of 5, 0. So let's explain what that means. So 5, 0. X is time, y is height in feet. Well, if my height is 0, what does that mean my ball has done? It means my ball has hit the ground, because at 0 height, you're on the ground. So that tells me that at 5 seconds, the ball hits the ground. Now you're probably wondering, well, what happened to negative 3? Well, if I were to graph negative 3 on a coordinate plane, yes, it would be, if I were to graph this whole parabola, it would cross the x-axis at negative 3 and 5. But remember, this is a real life problem. So we can only look at the first quadrant. All those other x and y's don't matter because the first quadrant is where x and y are positive. So let's review. If we want the initial height, we find the y-intercept. If we want time at max height, or we're maximizing something, we want the vertex. If we want to know when that object is going to hit the ground, we want the x-intercept. Initial height, y-intercept. Maximum height, vertex. When does it hit the ground? X-intercept. All right, let's try one. F of x equals negative 16x squared plus 50. And that models the height of a rock dropped from a height of 50 feet. Exactly when does the rock hit the ground? So hitting the ground, let's remember back to the cat and the ball example. Hitting the ground, that's the x-intercept. That's when y is 0. So I'm going to plug 0 in for f of x. And then I just have to solve. Well, when we're solving this, we have to get x squared by itself. So we subtract 50, and then we divide by negative 16. So I get 50 over 16. Now I know all of your mathematical training up to this point has gone, we can simplify that. Well, yes, we can simplify it. But let's think ahead. Let's stop for a minute and not be robots and just keep performing the math. Let's think. To undo the square, we're going to have to take the square root. So to undo the square, we're going to have to take the square root. Well, if I simplify that, dude, 16 is a perfect square right now. But if I simplify it, that's going to be 25 over 8. And 8 is like not a perfect square. So what we're going to do is we're going to leave it, because simplifying it would make my life so much more complicated, because 16 is already a perfect square. So to solve for x, we're going to have to take the square root of both sides. Okay, so I'm going to square root 50 over 16. Okay, so, well, when we take the square root of a fraction, if you remember, that's the same as taking the square root of the top over the square root of the bottom. And I just wrote 16 because my brain's thinking ahead. So my bad. We're going to take the square root of the top divided by the square root of the bottom. Well, square root of 16 is 4. But 50, not so much a perfect square. So we're going to have to break that up. So remember they taught you in geometry how to simplify radicals? So we're going to break it into prime factorization. 2 times 25 is 50. 25 is 5 times 5. So remember, because it's the square root, you got to have 2 of them before they can leave the radical. So I have 2 5s. So the square root of 50 is going to be 5. And then you're going to leave the square root of 2 inside. Because think about it. The square root of 50 is equal to the square root of 2 times the square root of 25. Well, the square root of 25 is 5, but the square root of 2 gets left behind. Now, notice here, we said exactly when to. So I don't want you changing this to a decimal. The minute you change it to a decimal, it becomes a decimal approximation, and it's no longer exact. No longer exact. So we want to leave that as 5 square roots of 2 over 4. Now remember, we put the radical there. So think back to what I said with 4.1, because we put the radical there. It was not there before. We put it there. We have to put plus or minus because we have to think of positive and negative. So plus or minus 5 square roots of 2 over 4. Now, remember though, x represents time in this problem. Can time be negative? I don't think so, Scooter. So we're just going to leave it as x equals 5 square roots of 2 over 4. Now, it doesn't want it as a coordinate point because it doesn't say, hey, what's the x-intercept? It says, when does it hit the ground? So we just look for that x part of the x-intercept. So time can't be negative, so x is going to equal 5 square roots of 2 over 4 seconds. All right? Last example. So it says f of x equals negative 3x squared plus 12x plus 50. That models the money earned by a business when they sell X number of cat collars. Find the number of cat collars which will produce the maximum amount of money, and then also give the maximum amount of money earned. So I know this is a quadratic, and so maximum. So think back to our cat and ball example. Maximum. First of all, this guy's going to open down because A is negative. So maximum of a parabola that opens down. That's my vertex, right? That's my vertex. So I'm going to do negative b over 2a to find the x value that maximizes the profit. So I want the maximum. I want the vertex. So again, x equals negative b over 2a. B is positive, so it becomes negative 12 over 2 times negative 3, which is negative 6. So negative 12 divided by negative 6 is 2. So I know that I will maximize my profit if I only sell 2 cat collars. Well, what if I want to find out how much money I earned? I plug it back in. So I plug 2 back into f of x. and I find out that when I sell 2 cat collars, I maximize my profit at $62. So I find out that 2 cat collars produces a maximum profit of $62. On a side note, y'all, that means those cat collars are like $31 each. They better have like crystals and all sorts of bling on them for a $31 cat collar. But anyways, probably not a good business model. But to answer this question, 2 cat collars do produce a maximum profit of $62. All right? And that is it. That is the end of the lesson. All right, so you're now going to go complete your homework, worksheet 4.2, and that's it. And we'll see you back next time for notes 4.3. All right, have a good one, guys. Please, please, please wash those hands, wear your mask, practice social distancing, be safe and be careful, and we'll see you back next time. Have a good one, guys. Bye-bye.